The second question is x of n is equal to u of minus n, let me see, plus 1. Okay. So this is the second question, alright. So here itself you can immediately understand that this has two operations. So you need to apply two properties. What are those two properties? One is the time shifting property and the other is the time reversal property. Okay. So we know that Z transform of u of n is equal to 1 by 1 minus Z inverse, right, where the magnitude of Z is greater than 1. Okay, maybe I can rewrite this here itself, so I don't have to write it again. So this will become Z by Z minus 1. Okay, and the ROC is magnitude of Z greater than 1. Okay, so now you're going to apply time shifting theorem and time reversal theorem here. So which one of these two theorems you're going to apply first? Now that is a very good question you need to ask. Okay, just like before, for when you are applying any operations that you have studied before, if you're applying any operations or if you're going to draw any graph on a paper, when you're going to draw a graph that looks somewhat like this, first you apply the shift operation and then you apply the scaling operation or time reversal operation. So that is what you are doing over here. So here what I'm going to do is that first I'm going to find my Z transform of u of n plus 1. I'm going to find the Z transform of u of n plus 1, and after finding the Z transform of u of n plus 1, then only I apply the time reversal property, and hence I will find the Z transform of u of minus n plus 1. See, this is how we do this problem. First we apply the shift, find the Z transform of the shift time shifting property, and then we apply the minus n plus 1. Then we apply the time reversal property. This is how we do the problem. Okay, so here, so we know that Z transform of u of n is Z by Z minus 1, right? And also we know that Z transform of x of n plus 1, this is time shifting property, right? X of n plus 1, you need to understand there are different values of this shifting property, right? So I suggest you need to learn x of n minus 1, x of n minus 2, x of n minus 3, x of n plus 1, x of n plus 2 and x of n plus 3, and you need to study all these properties so that whichever they are asking the exam, you should be able to write it fast. So here it is a transform of x of n plus 1, which is nothing but Z into x of Z minus Z into x of 0. Okay, so here basically the initial conditions they have not given, so the initial conditions are assumed to be 0. So this term is equal to 0. Okay, you don't even have to write this you don't even have to write this term for these kinds of questions. This question you are mainly applying when you are going to find, when you are trying to analyze an LTI system, then only you consider the initial conditions. Here initial conditions are not required, so all initial conditions are always equal to 0. So therefore this is nothing but Z into x of Z. Okay, so Z of x of n plus 1 is nothing but Z into x of Z. So in other words, Z transform of u of n plus 1, u of n plus 1 is nothing but Z into, what is the x of Z over here, is Z by Z minus 1. So Z by Z minus 1. Okay, and your ROC remains the same, no doubt. In other words, this is nothing but Z square by Z minus 1. Z square by Z minus 1. And the ROC is mod Z greater than 1. Okay. So now what I'm going to do is I'm going to apply time reversal property, right? Time reversal property, that is, we know that Z transform of x of minus n is nothing but x of Z inverse, right? X of Z inverse. So which means that the Z transform of u of minus n plus 1 is nothing but replace every Z that you see here with Z inverse. So this becomes Z inverse raised to 2 by, this becomes Z inverse minus 1. Okay, and the ROC also will become opposite. Z inverse, right? So Z inverse greater than 1 is nothing but Z mod Z less than 1. So here this becomes z raised to minus 2 by z raised to minus 1 minus 1. Okay, if you want, you can even make this answer a little bit more beautiful. You will get the answer over here as, that is z of u of minus n plus 1 is equal to, this becomes 1 by z square by 1 by z minus 1, or in other words this becomes 1 by z square by 1 minus z by z. So this z and this z square will get cancelled. You get, so you will get, basically you will get 1 by z into 1 minus z. Okay, and mod z is less than 1. This is your answer. Okay, so this is how we do the problems. So here basically we have applied both two properties here. One is we applied the time shifting property, okay, and then we apply the time reversal property, right? So let's do the next question. Next question is u x of n is equal to u of minus n minus 2. Now I want all of you to do this question by yourself. Okay, pause this video, do this question, and then compare the answer with what I got. Okay, that's how we learn, right? So let's do this problem. X of n is equal to u of minus n minus 2. So basically x of n is equal to u of minus n minus 2. Alright, so here we know that is a transform of u of n is equal to 1 by 1 minus z inverse, with its ROC is magnitude of z is greater than 1. Okay, this is also can be written as z by z minus 1. Okay, and this magnitude is of z is greater than 1. Okay, so now I'm going to apply time shifting property. So first I write the time shifting property. We know that z transform of x of n minus 2, right? That's the time shifting property. X of n minus 2 is equal to, we have z raised to minus 2 x of z plus z raised to minus 1 x of minus 1 plus z raised to plus x of minus 2. Okay, so here basically the initial conditions are all equal to 0, so therefore z raised to minus 2 into x of z, right? This is the equation. In other words, the z transform of u of n minus 2 is nothing but z raised to minus 2 into z by z minus 1. Okay, or in other words, this is nothing but z raised to minus 1 by z minus 1, z raised to minus 1 by z minus 1, or in other words, this is nothing but 1 by z into z minus 1. Okay, and the ROC remains the same, right? The ROC remains the same. So now what I'm going to do is, since I have finished applying time shifting property, now I'm going to apply time reversal property. So that means this becomes, we know that is a transform of x of minus n is equal to, you see, this is what you need to understand, which property you are going to apply, right? Which property you are going to apply, that property I want you all to write it. Okay, so that in that case you'll score more marks in the exam, right? If you write the formulas, which formula you are going to apply, which property you are going to apply, that is much better also, right? So one thing is that there are two reasons. One thing is that you can even avoid any careless mistakes by looking at the properties. That's one reason. The second thing is that in the exam also you'll get more and more step marks because of this. Your step marks will increase if you write these properties and these formulas. So we know that z transform of x of minus n is x of s n inverse. So therefore the z transform of u of minus n minus 2, u of minus n minus 2 is nothing but, so here as you can see, So here, as you can see, here it is 1 by z into z minus 1. So what I'm going to do is that I'm just simply going to replace every z over here with z inverse. That's it. So it becomes, so this becomes 1 by z inverse into z inverse minus 1, right? Or in other words, this becomes, z inverse is nothing but z, so this will become z, and here it will become 1 by z, which becomes 1 minus z by z, which is z square by 1 minus z. Okay, this is your final answer. And your time reversal property, so that means your ROC becomes reversed, so that means magnitude of z becomes less than 1. Okay, so this is the answer. Now let's do the fourth question. Fourth question is x of n is equal to 2 raised to n u of n minus 2. Let's do this question. Okay, given x of n is equal to 2 raised to n u of n minus 2, right? U of n minus 2. Okay, so let's do this question. So first, as usual, I'm going to apply the time shifting theorem of u of n. So let me write the equation of u of n. Z transform of u of n is 1 by 1 minus z inverse with its ROC magnitude of z is greater than 1. Then what I'm going to do is, now I'm going to apply time shifting theorem to this. We know that z transform of x of n minus 2 is nothing but z raised to minus 2 x of z plus z raised to minus 1 x of minus 1 plus x of minus 2. Okay, and here initial conditions are all 0, so therefore the equation will be z raised to minus 2 x of z. Okay, z raised to minus 2 x of z. So in other words, the z transform of u of n minus 2, the z transform of u of n minus 2 is nothing but multiply this function with z raised to minus 2, right? Or multiply this, in other words, this becomes z raised to minus 2 by 1 minus z inverse. Okay, this is it. So I think now I'm going to just simply rewrite this equation, right? Remove all this inverse power over here. So that means 1 by z square by 1 minus 1 by z, which is nothing but 1 by z square by z minus 1 by z, and this z will get cancelled and this z square will become z, so which means your answer will be 1 by z into z minus 1. So now we found the z transform of u of n minus 2. Okay, so now what I'm going to do is I'm going to find the z transform of 2 raised to n u of n minus 2. Okay, so for that, which property you are going to apply? The property you are going to apply is time scaling property, right? According to time scaling property, we know that the z transform of a raised to n x of n, the z transform of a raised to n x of n is equal to x of a inverse z, right? A inverse z, and its ROC such that, okay, that ROC is such that it is greater than a, right? Greater than a. That's how it is. Whatever number is here, that number will be greater in the ROC sign. Okay, so this is the equation. So in other words, here a, the value of a is 2. In the given question, the value of a is 2. So which means that this is z into 2 raised to n x of n is equal to x of 2 inverse z, right? Or in other words, this is nothing but x of z by 2. We write like this, x of z by 2. Okay, we already found that z transform of u of n minus 2 is nothing but 1 by z into z minus 1, right? And therefore the z transform of 2 raised to n u of n minus 2 is a transform of 2 raised to n u of n minus 2 is nothing but replace every z with z by 2. That's all. So 1 by z by 2 into z by 2 minus 1. Okay, and your ROC is a magnitude of Z is greater than 2, right? In other words, this is nothing but, maybe I can take this 2 as the numerator, Z into, and also here also it will become Z minus 2 by 2, right? In other words, this is nothing but 4 by Z into Z minus 2, and the magnitude of Z is greater than 2. This is the final answer. See? So this is how we do the problem, right? That is, we combine, first we apply, if you see any theorem, first we apply the time shifting theorem, and then we apply the time scaling and time reversing property, okay? So this is how we do the problems, okay? So now for the remaining problems, I will complete in the next video, okay?